Hello, my name is Jesse Helms and I am the Service Bureau Lead for Intermountain 3D, and today I'm discussing how utilizing scan-based reverse engineering provides us the ability to enhance the overall design and engineering effort of product development and advanced prototyping. This video is part one of a multi-part series where I will discuss the scan-based reverse engineering of an actual customer part, and I'd like to thank Turbo Air of Boise, Idaho for allowing us to highlight a part we previously did for them. As you can see by the provided part, it is badly damaged and worn. Our goal is to extract enough data from the part in order to create a detailed CAD model that can be printed for test fit utilizing our high definition SLA, then modified as needed in order to print in a production grade material that will be used as a final end user part. The scanning of the part starts with the setup of 3D Systems Capture Scanner. Along with an integrated turntable, we will scan the part and capture mesh data with accuracy that cannot be attained through conventional tools, especially on a part with any type of surfacing. By far the most important tool in this process is the reverse engineering software. And in this case we are utilizing Geomagic Design X. As you can see with the interface, we have several control options when scanning, including the number of scans completed in a 360-degree rotation. In this example, I have the turntable set to 4 scans, and we'll go ahead and get this started. As the scan begins, you will see the scanner captures a 3D image of the part in its current position and generates 3D mesh data. The table will then rotate to capture another 3D image, again creating further mesh data. These sets of data will automatically align, assuming there is enough overlap of geometry. As we can see at this point, we're about halfway through. We got 2 scans. We can see everything is aligned, and we can also see that there's plenty of overlap. So the 4 total scans in this complete scan should be enough to capture all the data that we need. So we have one more scan after this one. Again, you can see that everything is aligning. We can see in our interface that we have almost a solid model at this point. We might have even been able to get away with 3 scans, but having a little bit of extra overlap is never a bad thing. Once the scan is complete, it's going to ask us a couple questions. We're going to go ahead and close out of this so I can show you that we have 4 distinct scans here. We can turn off and on those individual scans. The software calls them capture meshes. And at this point, we're going to actually align this data. While the software does align automatically, we can always refine the alignment. So we're going to go ahead and do a refinement here just to get a little bit higher accuracy on the alignment. And as you can see in these tools, we have a lot of different controls, a lot of different settings that we can adjust. We'll go with the auto settings right now. And as you see in the capture scan data, you see how the colors actually join together a little bit better, have a better overlay. So at this point, we'll go ahead and create one single mesh. Because again, we have 4 distinct meshes here, and we want to join this and merge these meshes as one mesh that we can work with and start to prepare for the next step. So we go through the mesh buildup wizard. It allows us to do some stuff, including delete data that we don't need. We can come in here and do another alignment, but since we already did the alignment, we're going to go ahead and skip this step. Now we're going to come in this section. Again, we have more controls. This is the actual data merging section. We're going to go ahead and do an HD construction, and we're going to leave it to the highest settings for the most part. The only thing we're going to leave on the lower end is the hole fill. We don't want to fill too many holes at this point because we don't want to have stuff that we need as a hole, because this part actually does have holes in it. We want to leave those alone. So you can see it's processing. Depending on how much mesh data you have, depends on how long it's going to take to process. If you have 20, 30 images, it will take a lot longer. As you can see, this did not take too long, and we have one single mesh at this point. This is a high definition mesh, very clean for what it is, and we should have enough data here at this point to get what we want for the next step. So in the next video, we will go to alignment, and we'll do some other tools to get this prep for pulling data off of.